Hello. So I'm going to talk about the content in Chapter 2, Input, Process, and Output in this video. So these are the slides that are posted in the Canvas module. So you can follow along with those or review those on your own time if you want. So Chapter 1 really talks about the process of designing a program or designing a set of logic to solve a problem. And the way we do this in computer science and in programming is we take a problem and we break it down into small pieces, and then we design those pieces using pseudocode and flowcharts to help us come up with a solution to the problem. And then we translate those flowcharts and pseudocode into actual code. And in this course, we'll be using C#. And then we make sure that the code is correct, that we didn't make any typos or syntax errors. And then we run the code to make sure that it actually works. Sometimes we make a typing mistake, which is known as a syntax error. Sometimes we make an arithmetic mistake or some other type of logic error where the code is syntactically correct, but it doesn't do what we want it to do. The process of finding those logic errors and syntax errors is called debugging. And once we have written the code and found all the errors and debugged it, then hopefully the program will do what we want it to do. The process of writing a program follows generally this flow. We design the program, we write the code, we correct the syntax errors, we test the code to make sure it works, we debug it, and then we will go through back and forth through this cycle several times until the code is correct. Okay, but before we can design a program and begin writing flowcharts or pseudocode, the first thing we have to do is understand the problem. So what is it exactly that the customer wants? We do this by reading the problem. So if we look at our homework assignments, we'll see that we're going to do a land calculation. So in this case, we want to be able to convert a number of square feet into a number of acres. So we understand what the customer wants there. They want to be able to take one number that represents land area in square feet and convert it to land area in acres. So once we've determined that we know what the problem is, then we figure out a series of steps that will be taken to solve the problem. Typically, we write pseudocode, and we'll be writing a lot more pseudocode than flowcharts in this class. But pseudocode is like fake code. It's not actually code. You can't send the pseudocode to a compiler and actually execute it. But it does have a procedural aspect to it, and it tries to be very detailed to make sure that you're really covering all of the specific steps. So in this case, we see here that we're going to say display, enter the number of hours. We're going to say input the hours. We're going to say display in the string, enter the hourly pay rate. We're going to say input. So you can see that we're going through a lot of different steps here. Every little thing that we're going to write code to actually do once we take the pseudocode and begin translating it into C#. Okay, pseudocode has no syntax rules, but it does have some requirements. So in this case, we want to make sure that we always have the command up, right here at the beginning. So in this case, display, and then we have a series of parameters. So in this case, we have display, and then we have a single parameter, which is the string that we want to display. Here we have input as the command, and then we have the variable that we'll actually use to receive the input. In this case, the input's from the user. In some cases, input might come from somewhere on the internet. It might come from some other type of device that's connected to your computer. In this case, we're just taking input from the keyboard from the user. We have the set command, and then this set command has a formula that goes next to it, and the formula has a variable on the left, and then that is the receiver of this formula, hours times pay rate. So even though we say there are no syntax rules for pseudocode, there is some structure in that you want to make sure that you have the command and then the parameters following the command. We also want to make sure that our pseudocode is neat, that we have clean indentation. This one is in italics. You don't have to write pseudocode in italics, but that's just for purposes of presentation. But you want to make sure that you have good indentation, that everything's lined up correctly. If you're using capitalization at the beginning of your command, you want to be consistent about that. Either use it all the time or never use it, but try not to switch back and forth between it. You have grammatically correct statements, for your prompts and things like that. And you have well-named variables, which we'll get into here in a little bit. We also use flowcharts to describe and plan out the code that we're going to write. Flowcharts can be very useful if you have very complex algorithms, or if you have situations where you have a lot of different things that might happen in the code. In this case, this is a very simple flowchart, and this is actually a flowchart that is representing the pseudocode that we saw in the previous slide. So here we use a couple of symbols for flowcharts. We use this oval here, which is to indicate the beginning and the end of the code. So we see that here, start and end. Okay. We use this parallelogram, which we use for input and output. Anytime you're writing something to the console, to the display terminal, or you're writing something out to a printout or a report, or you're generating a PDF document, or if you're outputting data to a network folder or something like that, you will always use this parallelogram for input or output. Here for in the rectangle, we use this for process. So we can see in our example that we have the start symbol here. So we have our oval. Then we use an input, a parallelogram, to display, to say this is output. So we're going to say display, and then the string that we want to display. We have an input statement here, also in a parallelogram. We repeat that again. Here we have the rectangle, which is where we're actually doing our calculation. So this is the setting the gross pay to equal hours times pay rate, and then we're going to output the result. Okay, so here it's also worth noting that we have arrows that give us the direction of flow. So we're going to start here. This is a procedural flow. So we're going to start here. We're going to follow the arrow. We're going to get to this box. Then once this box is complete, we're going to follow the arrow. We're going to get to this box. You always want your flow charts typically to go down or to the side. When we get into decisions and loops, we'll have flow charts that start moving to the side. It's very rare that you want flow charts to go up. Typically, you want flow charts to go down. If you need flow charts, if you run out of space at the bottom and you feel like you want to go start moving up the page instead of down, then we use these connectors. So in this case, here we've run out of space in our drawing area, whatever that is, and we still have more logic, so we can put a connector in and say we're gonna once we get to point A here, we're gonna jump over to point A here and then continue. So this way, our flow chart is going to continue to go down the page. Okay, so that's very important that your flow is always down or to the side if you're using an if statement or loop. If you run out of space on the page, you can use a connector here to move to a different column on the page. You can also use a numeric connector if you want to move to a different page. So in this case, if you've completely filled up the page, the entire drawing page on your flowchart, then you can say, in this case, move to page number 2, and then we can connect thusly. In this class, you will not have any flowcharts that exceed a single page. So if you are working on a flowchart and your flowchart is more than one page, then you've made a mistake, and you should reconsider what you're doing. Typically, the problem that you'll have at this point is that you've run out of drawing space because your boxes are too big, or you're using a font size that's larger than it needs to be, and you're just wasting space on the page. So in our class, we will not be using any flowcharts or pseudocode that exceed a single page. Okay, so here we talk about output is data that's being generated and displayed. Input is data that we're retrieving. In our case, almost all of our data will be, at the beginning of the course, will be input from the user. We'll ask the user to enter some data. We'll store that in a variable, and then we'll do some processing on it, and we'll produce an output. So this is the flow that we're gonna repeat over and over and over again for every piece of code that we write. A single program will follow this input, process, output in many ways. Sometimes the process is to call a module or another function or another piece of the program. So while your program as a whole is going to have input, processing, and output, you'll also be repeating this input, process, and output sometimes, dozens of times in your programs as they become more complex. So always keep in mind, you want to input, you receive some data, get some input, you want to do something with the data that you received, do some kind of process on it, transform it in some way, some kind of mathematical function, some kind of interpretation, or some kind of process, and then you have some data that's produced from your process, and you output that in some way, either by putting it back onto the console for the user to read, or maybe by writing it into a file or storing it into a database. Okay, so in our pseudocode and in our flowcharts, we're going to use the display command. okay, as the keyword to show that we're writing things to the screen. So when you use display, whatever the string literal that comes after this is what you're going to display. Okay, so in this case, when we say display Kate Austin, what's going to happen is on the command prompt, we're going to see this appear. Okay, so when you want to write something to the console so that the user can see it, we're going to use the display keyword. When we want the user to enter something, we're going to use the input keyword. So in this case, we say display what is your age, and then we say input age. So when we convert this to C# code, the program will stop and it will wait for the user to type something in using their keyboard. Whatever they type in will then be stored in this variable named age. And then we can do some kind of processing on that. Okay. So variables have some requirements in the way that they're named. Okay. In C#, and the requirements are fairly standard across languages, but you do have some stylistic differences between different languages. So we're going to be using C# as our programming language in this class, and so we'll talk about the style that's required in that. So your variables must be a single word. They have to, no spaces can be, you can't have a variable name that has any spaces in it. So it has to be a single word with no spaces. Punctuation is generally not allowed. You can use underscores as a punctuation, but things like colons and commas and things like that are generally not allowed. Dashes or hyphens and underscores are generally acceptable. However, in C#, we typically don't use any punctuation. We only use letters. We never start with a number. So we don't ever want our variable to start with a number. You don't want to have the digit 1 or the digit 2 as the beginning of your variable. You might include a digit somewhere down the line in the variable name, but never as the first character. And usually it's rare to see variable names that have numbers in them. That it does happen, but it's pretty rare that you'll see that. And then we also want to make sure that the variable has something that's named appropriately, that the name that we've given to the variable is meaningful in some way. So we don't want to name every variable X unless we're solving the Pythagorean theorem, right? So we want to use a variable name that has some kind of meaning. So if we're asking for the user to enter the square feet of an area, then we want to name our variable something like square feet. And to use two words in the variable name, we would use something called camel case, which here is you would use the word camel case here as a variable name. The first word camel is going to be the first word in the variable name is going to be lowercase, and then when every new word begins, you will uppercase the first letter of every subsequent word. If you have variable names that have 3 or 4 or 5 words in them, they're probably too long. Typically 1 or 2, sometimes 3, but usually 1 or 2 should be plenty to get you there. Always, and in C#, we always want to make sure that we start variable names with lowercase letters. This is important because in C# we start method names or module names with uppercase characters, and so we're going to want to make sure that we're using lowercase characters for variables and uppercase for methods and modules, so that we can distinguish them easily. So lowercase for variable names. Okay. You can, we're going to be setting most of our variables, or will be set by an input when we ask the user for something, but we can also set a variable according to a function. In this case, we're just setting the variable to a literal. So this is an integer of 20, and that we just refer to that as a literal value. Okay, so this is an integer literal of 20. We see here that this is 2.75 down in this example here. That is what's known as a double literal of 2.75. So integer is a type of variable, and double is a type of variable. And so in those, we refer to those as types or data types. We have some math that we can use, some math operators that we can use on variables. So these are formulas. These are the ones that you're familiar with from your high school math days or college math days. We have addition and subtraction using the plus and minus. For multiplication, we use an asterisk. That that multiplies one number by another number, and we use the slash for division. We also have a modulus function, which is probably not one you're familiar with, but modulus essentially divides one number by another and gives the remainder. So we'll use the modulus function in our work primarily to determine if one number is a factor or multiple of another number. So determining if a number is even, we use the modulus. In pseudocode and flowcharts, we'll use this little upper caret or the hat symbol to refer to exponent. But just know that in most programming languages, we're not using the exponent as the symbol. So while we might use this in pseudocode, this is not going to translate directly to C# code once we get to that point. Okay, so when we define variables, we have to give them a data type. Okay, and so the data type says what kind of data is going to be stored in this variable. Okay, so we're going to be using primarily 3 data types. We're going to use an integer data type, which stores only whole numbers. So think of 1, 2, 3, 50, 59, 61, 87. Those are integer numbers. We're going to use real, or in C# they're referred to as decimals. So we're going to call them decimals. But that is a number that stores a number with decimal precision. So 1 or 2 or 3 might also be a decimal number. In that case, it's 1.0, 2.00, 3.0, etc. Or we could store 2.95. We could store 8.37. We could store 3.1415. So we can store several decimal numbers, several numbers in the decimal precision using a decimal data type. We also have a string data type, and the string data type is any series of characters. Now keep in mind that series of characters might be numbers. So we could have a string data type that looks like an integer, but because we've defined it as a string, it's actually going to be a string. So we could define a string as 1, 2, 3, whereas we define that as an integer, it would be 123. But defined as a string is actually 1, 2, 3. We can also, typically we'll use strings to use alphanumeric characters. So these would be things like, please enter your age, please enter the square feet, things like that. So those are going to be string data types that we'll be using for those. Okay. So when we are using variables, we're going to want to declare them before we use them. So in this case, we're going to declare a real or a decimal data type, and it's going to be called test1. And then we can use test1 using a set or an input command, okay, and we can set it to something else. When you declare a variable, it is initialized to the default value of the data type. So for numeric data types, integer and decimal or real, the default value is going to be 0. So for an integer, it will be 0. For a decimal or a real data type, it will be 0.0. A string data type will typically initialize to an empty string. So that is just a string data type with nothing in it. Okay. So different data types will initialize to different default values, but for the ones we're using, typically the numeric data types always initialize to 0. String data types always initialize to empty string. We can also use something called a constant. In this case, if we want to, sometimes we'll have a need for this. So for example, in this case, we're using a constant named interest rate, and it's a decimal value or a real value, and we're defining it as equal to 0.069. The difference between a named constant and a variable is that a named constant can never change. So once the program is executed, the constant is defined and it's assigned a value, and that value is immutable, which means that your program can never change that. It's important, we want to use named variables in cases where maybe we want to use the same number in different places throughout our code. So in this case, maybe the interest rate occurs in multiple calculations in our program, and we don't want to have to use this literal over and over again. We want to be able to call it the interest rate, so that if it ever changes, then it's very easy for us to just make that change in a single place. Okay. So here when we go to, as we're designing a program, we can say we want to calculate the batting average for any player. So the batting average is going to equal the number of hits divided by the number of times at bat. So the first thing we have to do here is determine what's required to solve this problem. So what do we need as input? What are we going to do with the input? And what are we going to do with the output? Okay. So we know that we're going to have to, the input is going to be the number of hits and the number of times at bat. We need both of those things in order to calculate the batting average. So we're going to have to ask the user to enter both of those things using a display and an input combination, okay? And then we're going to run a numerical calculation on those two values to calculate the batting average. So this is our process. And so in that case, we're just going to divide the number of hits by the number of times at bat. And then, then we're going to produce an output, which is we know what the batting average is, and we're going to report that back to the user in some way, okay? So here's pseudocode that we are writing to do this. And so in this case, we're going to declare integer of hits, we're going to declare integer of at-bat, and we're going to declare the batting average as a decimal value. So we've declared all of our variables here at the beginning. We're then going to do a couple of display and input sections. So we're going to say display into the player's number of hits. So this is a string that we're using on the display command, and then we're going to say input hits. Then we do that same process again, a display and input for the number of at-bats. Then we do our processing right here. This is our process. So set the batting average equal to hits divided by at-bat. And then we're going to do a display to produce the result. Notice in this case, we have the display, we have a string literal here, and then we have a comma, and then we have the batting average. So in this case, what we're doing is just saying, display the string, and then after the string, display this variable. And so you can see this is what the output would look like down here below. Okay, here is the flow chart that represents the same algorithm that we had for the pseudocode. We see we get a start here. We're going to we have a process. These are declarations, and so that's going to be a process box. So it's a rectangle. Then we have a display and input. So these are input-output boxes, and so we're going to use the parallelograms. Display and input for the at-bat. We have a process here to calculate the batting average. Then we use another parallelogram to display the results. Okay. So again, you always want to follow this process. What is the input? And then how am I going to collect it? What is the process? So once I have all the data, collected all the data through the inputs, what am I going to do with it? And that's my process. And then the output, what am I going to do with the results of my process? So I'm going to display it on the screen or send it somewhere else. And in our case, most of the work that we'll be doing, we'll be sending the data to the screen. Okay.